Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Counterproductive by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. A cage's product, the result of multiplying its digits together, exactly equals the number of cages with that product. And that's the product, which is the productive in the counterproductive, and we're counting them, which is the counterpart of the counterproductive. Note, if a cage has only one digit, that digit is considered to be the cage's product. So each cage, again, a cage's product is the result of multiplying it exactly equals the number of cages with that product. So say this has a product of, this is a single digit. Say it was a 9. That means there would have to be 9 cages, which would add up to, or would multiply to 9. So the digits in that cage must multiply to 9, if that's the case. And that's for all the cages in the grid, right? So if there was a 9 in a cage, that means there would have to be 8 other cages, 9 in total, which multiply to 9 exactly. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first things first. Let's count how many cages there are. And let's look and see, what's the longest cage? It's 3, right? So, because it's 3, that means the minimum would be a product of 6. We have 1, 2, 3, 4, 5, 6, 7 3-cell cages. How many 2-cell cages do we have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 3-cell cages, we'll mark it as pink. 2-cell cages, 1, 2, 3, 4, 5, 6, 7, 8. We'll mark as red. And the 1-cell cages will mark as green. So that's 1, 2, ooh, that's too many colors. Ooh, that coloring is way too bad. Okay, so there's 1, 2, 3, 4, 5, 6, 7. 7 3-cell cages. 1, 2, 3, 4, 5, 6, 7, 8. 8 2-cell cages. 1, 2, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 1-cell cages. 21 1-cell cages. All right, let me double check. 3, 4, 5, 5, 6, 7, 8. There's 4 here, 12, 15, plus 4 is 19, plus 2 is 21. So, there's 21 single-cell cages. So, what does that mean? How many unique single-cell cages are there? Hmm. Interesting. Okay. So it could be the numbers 1 through 8, right? Because we have 21 single cell. There are 36 cages in total. Um, Kind of the question though is, hmm. One thing you know is that the products can never be greater than 15 because single cells can never have a value of double digits, and you can only have 15 here for the products, right? Because you have two cells that are 8 and three cells that are 7. But I think it's almost certainly not going to be 15 because the only way you get 15 is 135 or 35. And you already have a contradiction here for that, right? That's interesting. Okay. What are the products of these then? So there's places where there's a 2 and a 3 set in the same box. And one of them has a 5 in it. So therefore, you're guaranteed to have at minimum the digits 1, 2, 3, 4, and 6. You could have. You can never have a multiplication that's going to be greater than 15 again, right? And 15 doesn't work because it's 135 specifically, and all of the products would have of the 2 and 3 cell cages would have to be 3 and 5, but we already have a 5 here, so that's not guaranteed. um, I think that's similar for 14. 13 doesn't work, obviously, so 13 is never going to be the case. 12 is pretty likely. 14 is never going to be the case either, right? You have too many combinations of 2-digit cells and 3-digit cells. Or sorry, 2 cell cages and 3 cell cages in the same box. There's 3 pairs of those. There's 4 pairs of those. So because of that, they're not never going to be able to get to essentially um, 13 or 14 because of that, right? You would have to have 14 cages each with that multiply to 14, and that's not going to happen because at least 4 sets have to be different digits. So I think, and 10 doesn't, 11 and 13 obviously don't work because those are prime. 10 is not going to work because that's 2 and 5. And you can only have, you can't have one here. You can't have one here. You can't have one here. So this could be 1. So these would not be possible to be 2 and 5. These would not be possible to be 2 and 5. So that's 4 you're missing already. That means you can only miss um, one more at most. And these combinations, 2 and 5 can only be one of these two here, and 2 and 5 can only be one of these two here. So you're guaranteed that, or 1, 2, and 5, and 2 and 5, obviously. So you're guaranteed that this can never be 1, 2, and 5 multiplied together. So you're guaranteed then that the product of, since one of these, this must be a combination of 1, 2, 3, 4, and 6. One of them has to be a double digit. There's no combination that you can have that will have, because 6 is going to be with 1 digit at least. And if it's with essentially 1, the other set would have to be 2, 3, and 4. And 2, 3, and 4 is 24, and that's not going to happen. So 6 essentially has to multiply with a greater than 1. It has to be 6 and 2 then. So you have 6 and 2, which means that you have 12 cage products. Because of that, you know that's 36, right? There's 36 cages in total, minus 12. That's 24 cages for the rest. Okay. And there's a guaranteed 4 single digits. Yeah, because there's 4, but there could be more, right? So there's only one double digit product that we have, and that's 12, because that uses up all 12 that we need. We have 3 extras, and they have to multiply to single digits because they're not going to be able to count enough double digits ones, but just by themselves. So the rest is all single digits. So we have 12 as a double digit. You can never have 7 and 1 together with 2, 3, and 4. Right? The 3 set, I think, almost always has to have a 1. Right, because you have 2, 3, 2, 3, and 2 would multiply to 12. But there's no cages which you can have 3 non-unique set or digits. Every cage is in the same box or in the same row or in the same column. So there have to be unique. So every time you have the 3 cell, it has to have a 1 in it. Okay, that's interesting. That means this is guaranteed to be 1, right? Because you can never multiply to 2, 3, and 4 without a 1. You always multiply to 2, 3, and 4 at minimum. And that's 6 times 4, which is 24, which is too large. So we know where all the 1s are. 1 has to be here. 1 has to be in all the 3 cell cages. 1 has to be there. So this can't be 1 here. 1 is one of those, so this can't be 1 here. 1 has to be one of these. 1 has to be one of these. Okay. This can never be 1 because we know we have a guaranteed 1 here and a guaranteed 1 here. So 1 in box 2 has to be one of these 3 cells. 1 in box 8 also has to be one of these 3 cells. This can't be 1 because of the one of these has to be 1 here. 1 has to be one of these 3 cells. That's fine. We know it's one of these 2 because one of the ones have to be here. Okay. So the rest of them are 24. And the rest of them must be 2 digits multiplied together. Okay. That's interesting. We have certain rows. Well, we have 2, yeah, we have 2 rows where we're missing entirely 1 digit. Okay. What does that mean? We have a couple columns, actually. 2 columns, we're missing just 1 digit also. Is that the same digit? Um, Possibly. Okay, so what are the ones that can't contribute to 12? So to multiply to 12, so to multiply to 12, you can only have 1, 2, 3, 4, and 6. We're only missing a single digit from 2 rows and 2 columns. Actually, 3 columns. So that means all the other digits must be part of some sort of cage except one, possibly. We are guaranteed 24 cages left. Five cannot be multiplied together. 7 can not be multiplied together, and 8 cannot be. 8 and 9 cannot be multiplied together. We could have a 7, 8, and 9, but we have 4 unique numbers in the single digits. So that means 7, 8, and 9 is right out. So 1 out of 7, 8, or 9 cannot be in the products. Can you be missing 2? I think the answer to that is no. Definitely not. Right? Because again, if you have 7, 8, and 9 as single digits in cages, first of all, that would take up all 24 cages that we have left over. We have 36 in total. We have 12 accounted for by the 12 products. And that leaves 24 left. 7, 8, and 9 would take up all 3 of them. But again, we have four single cage cells definitely in the same box. And I think in the same row. Yeah, row 9. Ah. That means 1 cannot be one of them. Well, it couldn't anyways, right? Because the thing is, what we're missing. We're missing a digit from 7, 8, or 9. We have to be, right? Because if it's not, it's you have to include 7, 8, and 9 in all the cages, and that adds up to a minimum of 24. And we have 24 cages left. So we wouldn't have another cage, which we are guaranteed to have because we have 4 separate single cell cages. So we have to be missing 1 from 7, 8, or 9. So first of all, that means this is 7, 8, or 9. This is 7, 8, or 9. This is 7, 8, or 9. I think, are those it? This can't be 7. Ah. This then must be 8 or 9. Because the remaining digits... Okay, so we are guaranteed a 7 in row 7 is going to be in a cage. And 7 can't be multiplied by any other. So 7 has to be a single digit, which means 7 has to be one of these two, which means this can't be 7. Eight can't be multiplied by 2. So one of these, this has to be a 7, 8, 9 pair. Right? Because the single digit has to be a 7, 8. You have to have a 7, 8, or 9 in as a single digit. That leaves the rest of these digits as a 1, 2, 3, 4, 6. We already kind of knew that, but 1 cannot be here. This is either 2, 6, or it's 3, 4 here. So how many... we are guaranteed 5 as a single digit, 7 as a single digit, and 8 as a single digit. 5, 7, and 8. Um, oh, there's no single digits in column 9 at all. That means 9 cannot be. Ooh, that's weird too. No, no, no. It works for every other digit except for 9, right? Since 9, there is no single digit in column 9. That means one digit cannot be a single digit multiplication product. You can't have a full 9 all the way through. So one of them has to be at least a non-9. 9 could be 1 times 3 times 3, but again, none of the cages can have unique. They all have to have unique digits because they're all in the same box, the same row, or the same column. So if you were to have 9 as the non as sorry in a cage, it would have to be in single cell or double cell cages. And this, but the problem, it cannot be in a triple cell cage because that would multiply to 18 at minimum. 9 plus 9 and 1 and 2. If we tried to have a 9 here, though, 1 can't be here. So therefore 9 cannot be in 9 cages. Therefore 9 must be the one that's being left out. So this can't be 9, this can't be 8, this is 9. This has to be 9 also because it's not in a cage. So this is a 7-8 pair here. Again, 9 cannot be in any cages. So 9 has to be here. 9 in column 8 has to be here. So this is a 9. 9 in column 6 has to be here because there's everything else is in a cage. So 5, 7, and 8 all have to be in one cell cages. And the ones that are missing 8, so 8 has to be in every single one cell cage possible. I guess it could be in a doubles cage if there's a 1 possibility, but it can't be in column 8. In column 9, that's not possible. So 9 has to be one of these 2 here. 9 has to be one of these 2. 9 can't be here. 9 has to be here. 9's one of these 3. Where's the 9 in row 6? It must be here. So this is 9, which means this can't be 9. So because of that, we have 5, 7, and 8 remaining. That's 20. So we have 4 cages left. So it's either 1 by itself and then 3 times, or it's 4 times. Okay. So every 8 has to be in a single digit. Ooh, but that's not true. That's not true. Because columns 1 and 9 both will not have a single digit represented, right? 7, though, does have to be in every other column possible. So 7 has to be one of these 2. Where is 7 in column 3? It must be one of these 2. So this can't be a 7 because of the 7 in that box. 7 in column 3 has to be in that box. So this is a 7. Column 4. And the thing is, the reason why we know we can have 8 be somewhere else is 2 and 4 multiply to 8. So that's possible there. But 7 is guaranteed, has to be in single boxes or with a 1. Well, because of column 1 and column 9, not having any possibility to have single cell values, that means the rest of the columns must have single cell values of 7 because we are guaranteed a 7. So this is one of these is 7, one of these is 7, one of these is 7. Okay. Do we have any rows? Yes, we have. Well, this is 7 already. Never mind. So 8 can be gained by having like 2 multiplied by 4. So that's a possibility. 1, 2, and 4, or 2 and 4 multiplied together. 5. In Okay. 7's one of these 4. 7's one of those 2. 7's one of these 3. 7. We are not guaranteed to have a 7 in this box. We are guaranteed to have a 7 here, so this must one of these must be 7. Guaranteed a 7 here, a 7 here. 7 here. We are not guaranteed a 7 here. Okay. To multiply together, right, in these cages, you have to have 2 times 4, 1 times anything as a single digit, but these are not single digits. So these have to be 1, 2, and 6, 3, and 4. 2 and 4 are the possibilities that you could multiply together. Same with this. This is 2, 6, 3, 4. So this has to be 2, 3, 4, 6. This is a 1, 2, 3, 4, 6 triplet. Where are the remaining digits? What are the remaining digits in column 9? They have to be 7 and 8. And 8, again, cannot multiply anything without anything except with a 1 to multiply to a product that we can have all the cages add up to. So this can't be 7 because of the 7 in the row. So this must be an 8, which makes this a 7 here. That means 7 cannot be any of these digits. 7 in, we're missing a 7. So we have 7s outside of cages, specifically in hold up. This assumption is not good. 7 could actually be here. Okay. But the problem, okay, so then the problem with that is that 7 would guarantee to have to be in one of these cages here. And that's not allowed. Okay, so this is definitely guaranteed to be 7 and 8. Because if it were in the other cages, it would have to be with the singleton as a 1 for both 7 and 8. And that's not going to be the case, right? The 1 has to be in the 3-cell cage to give us a decent number that multiplies together. And if you have 1, 2, and 7, or 1, 2, and 8, that already multiplies to 14 and 16, which are too large for the cages that we have. So that 7 and 8 have to be here. And this is still the same. This is then 8. This is 7. Right. We now have... Right. So this logic was still always going to be the same. To multiply to a product that we can have the same amount of products in those cages, it has to be 12, right? Or 8 that you multiply together. Because we already have 5, 7, and 8 guaranteed. And therefore, you only have 4 as a product or 1 and 3 as a product. You can't have 2. So the single digits can never contain 2 or 6. Interesting. Anyways, we have 2 sevens that are outside cages. As singletons. And that means the rest have to be either in singletons or in 2-cell cages with a 1. The only possibility for those to be the case is in box 8 and box 2. But 7 can't be anywhere else in box 9 except in row 7, again because of the logic we had before. So this cannot be a 7, which means 7 is guaranteed in one of the singletons. 7 cannot be in row 3 because of the 7 in the row. So it has in box 2, it also has to be in a singleton. That means in box 3, where is a 7? It has to be a singleton because the 1, again, cannot be in the doubleton with the 7. And the 7 couldn't even be here anyways. So this must be a 7 here, which means this can't be 7. This is 8, which makes this a 7. 8 has to be one of these singletons. That's fine. But 8 can also be multiplied together to get by 2 and 4. Can 1 ever be... Oh, I guess 1 could be a singleton here. Okay. So let's do the digits. Only 1, 2, 3, 4, and 6 can be in the triplets. No 5. This can't be 1 here. 1, 2, 3, 4, 6. In the doubletons without 1, you can only have... You can't even have 2 and 4 in these. These have to be 2, 3, 4, 6. So these must multiply to 12. Period. So this is a 5-7 pair here. Because 5 can only be with 1 multiplied together. And in box 3, there's no other place for the 5. There's a lot of singletons in box 6, so that's okay. But 7 is not one of them. So we are guaranteed there have to be 5 unique digits in the singletons, which means it must be 1 and 3. So this must be 1, 3, 5, and 8 here. And 1 cannot be any of these. That eliminates 3 and 5 and the rest of the 1, 3, 5, 8 and the rest of the region. So this must be 2, 4, or 6. Whereas the 1 in this 3-cell cage, it has to be here. So this is 1, which eliminates 1 here. This can't be 1 either. One of these is 1 here. So 1 can never be in the rest of the singleton boxes. That means this can't be 1. This can no longer be 1. Where is 1 on this 3-cell box? It has to be here. So this can't be 1 here, which means the 1 in box 8 has to be here. So this is 1. This could be a singleton. It could be 5 or 8. We have 1 and 3 remaining in the rest of the singleton boxes. 5 has to be... Okay, so 8 cannot be here. This becomes a 1, 3 pair here, which eliminates 1 and 3 in the rest of the column and the rest of the box. So this becomes a 5, 8 pair. This cannot be 3. So we know what the products are. There's 1, 3, we have 5, 7, 8, and 12. 1 can no longer appear in the singletons, so they have to be 3, 5, 7, and 8. Well, we have a 3, 5, 7, 8 triplet or quadruplet in row 9 now, which eliminates 3, 5, 7, 8 in the rest of the column or the rest of the row. So this can't be 3. These digits cannot be 1. It must be 2, 6, or 3, 4. Five can never be in a double pair unless it's with 1. So 5 has to be here. Where is the 8 in box 1 then? 8 has to be here, which means none of these can be 8. 8 can't be here. Where is the 8 in box 7 then? It has to be here. Therefore, 8 has to be one of these 3, which isn't that telling us that much. This can't be 8. This is a 3, 5, 7, 8 quadruplet in box 8, which eliminates 3, 5, 7, and 8 in the rest of the box. So that leaves us with 2, 4, 6, and 2, 4, 6, and 9. Okay, well, the 2 must be multiplied together with 4 or 6 here. So 2 has to be one of these 2, which means this can't be 2. Same with this one. This has to be 2 multiplied together with a 4 or a 6 to multiply to 8 or 12. So this cannot be 2. Therefore, 2 is guaranteed here. This can't be 3. Eight has to be one of these singletons, so that's 8, because it cannot be multiplied with 2 other digits. These multiply to 12 each. Okay, let's start counting the ones that multiply to 12. It has to be these. 1, 2. Okay, we're gonna make the 3s orange. We're making green. All the 3 cell cages that multiply to 12 are green. All the 2 cells we're going to mark as pink. This must be pink. This cannot be 3, right, because 5 and 7 can't be here. So it must be, this has to be a 5, 7 pair here. That means 5 is also here. This is 2, 3, 4, 6, and it cannot be 2 because of the 2, 4, 6 pair. But these must multiply to 12 because otherwise it's not going to work. Right? If this is 2, 4, that makes this 3, 6, which multiplies to 18. But we don't have 17 other cages to add up to multiply to 18. So this must be a 2, 6 pair. That eliminates 2 and 6 in the rest of the row and the boxes. So this is a 4, 9 pair. This can't be 6. This is a 3, 4 pair, which eliminates 3 and 4 in the rest of the box. Therefore, this becomes a 1, 2, 6 triplet. This 4, 9 pair eliminates 4 here. And this must multiply to 12, so it has to be 2 and 6 here. Therefore, this can't be 2 and 6 here. This must be 1, 4, and 3. So this is 3. This is a 1, 4 pair. That means 3 cannot be here. This 3 eliminates 3 here. This 2, 6 pair eliminates 2 and 6 here. So this is 1, which means neither of these can be 1. So 1 in box 1 cannot be here. That means it must be here. So this is 1, which means 1 cannot be here, which means 1 in box 3 has to be here. So this is 1, which makes this 4, which makes that 1. This can no longer be 4. So we have 1, 2, 3, 4. So we have 4 3 cell cages multiplying to 12. We have 1, 2, 3, 4, 5. We need 3 more cages then. This is a 4 or 6. It must be multiplied with a 2 or 3. Okay. This 3, 4 pair eliminates 4 here. So this is 2 or 6, which means this must be a 2, 6 pair to multiply to 13, or 12, sorry. So this is a 2, 6 pair, which means this can't be 2 or 6 because of a 2, 6 pair in the box. Therefore, this is 4, and this is 3. This 4 eliminates 4 here, so that's 6, which makes this not 6, that's 2. This must be a 4 then. This 2 eliminates 2 here, so that's 6 and 2, which eliminates 2 here, so that's 6 and 2. This then multiplies to 8. So this must be a 3-digit cell. Since it has a 6, this has to be 2 to multiply to 12. So we have a 10th one. This becomes a 3, 4 pair, and this must be 5 and 8. Because 5 and 8 can only... Oh, 5 could be here. Never mind. This is not just... Yeah. So this could be 3, 4, 5, or 8, because it's multiplied with a 1. This can only be 3 or 4, though, because it's going to be multiplied with 2 other digits. Well, we have a 3, 4, 3, 4 pair in column 3, which eliminates 3 and 4 in the rest of the column. So this can't be 3 or 4. Therefore, we have 2 and 6 here. This has to be 1, 2, or 6. If it's 6 here as a 1, this would be multiplied to a minimum of 3, which would be 18, and that's not allowed. So this must be a 1, 2 pair, and it must be 1, 2, and 4 here. This can't be 4. This is 3, 5, or 8. This 1, 2, 4 triplet eliminates 1, 2, and 4 in the rest of the column, so this can't be 2. This is 6, which makes this a 2. This can't be a 2, 6 pair. It's 3 and 4. This 2 eliminates 2 here, so it's 6. This is a 6, and this is a 2. This 4 eliminates 4 here, so that's 3, and that's 4. Remaining digits in column 2 are just 3 and 9. That means this can't be 3 because of the 3, 9 pair in the box. Where is the 3 possible? Then in row 6, it can only be here. So this is 3. That means 3 cannot be here. That leaves this as a 5, 6, 8 triplet. And 6 cannot be here because of the 6 in the row. This cannot contain a 2, so this must be multiplied 3 and 4 at minimum. So this is also, and it can't be 3 because of the 3 in the box, so this is 4, which makes that 3. This can no longer be 3. Where is the 3 possible in box 8? It can only be here, so this is 3. This 2 eliminates 2 here, so that's 6 and 2. This is multiplying to 12 also. So we have 1, 2, 3. We have 1, 2, 3, 4, 5, 6 3 cell cages multiplying to 12. We have 1, 2, 3, 4, 5, 6 2 cell cages multiplying to 12. So there cannot be any more 2 cell cages multiplying to 12 or 3 cell cages. But I think we've already shown that, right? Right, we have a 2 cell cage multiplying to 3 and a 2 cell cage multiplying to 8. So that's all 8 2 cell cages. And then we have the 1 2 cell cage multiplying to 8 here. Okay, and this 2 eliminates 2 here, so this is 1, which makes this 2. 1 eliminates 1 here, so that's 3, which makes that 1. 3 eliminates 3 here, so 9, that makes that 3. This must be a 2 6 pair in row 3, which eliminates, this can't be 2 because of 2 in the column, so this is 6, that's 2. Okay, so we have, these are the 8s. We're gonna mark them as blue, I guess. So that's 1, 2, 3, 4. We have all the 3s left, so those are fine. This has to be 5, 7, or 8. 5, 7, or 8. These are all 5, 7, or 8. 4 cannot be in a cage singleton by itself, so this must be a 4, which means this can't be 4. That's 3, which makes that 4. That's 3 in the corner. We celebrate because we're getting close to solving this. This 4 eliminates 4 here, so that's 9, which makes that 4. 9, where's 9 in box 5? Can't be here, so it must be here then. Where's 6? This can't be 7 because of the 7 in the row. We have a 5, 8, 5, 8 pair in row 4, which eliminates 5 and 8 in the rest of the row. So this must be 6, which means this can't be 6 here. Where's 6 in box 5? Can't be here because of the 6 in the column, so it must be here. 7 again has to be in the remaining boxes. They have to be in cages. So this is 7, which means this can't be 7. This is 5. This can't be 5 or 7, so it's 8, which makes this a 7, which makes this 5, which makes that 7. This 7 eliminates 7 here, so this can only be 7 here, which makes this 5, which makes that 7. This 5 and 7 eliminates 5 and 7 here, so that's 8, which makes this not 7 or 8, that's 5. So we have 8 in 1, 2, 3, 4, 5, 6. If it's here, we have 5 in 1, 2, 3, 4. So 5 cannot be here because that would force a 5 here, and that would make 6 5s in a singleton cage, which is not allowed. So this must be 5, which makes this 8, which makes that 8. This 8 eliminates 8 here, so that's 5, which makes that 8, which makes this a 5. And that's how you solve it. It's not quite hard for me, but I do these sort of things quite often. So I don't know. For me, it's probably average, but for probably your typical Sudoku solver, I can see this being hard. Anyways, I hope you found this solve interesting and not counterproductive. But I hope you enjoyed this, and I'll see you next time on Frank Puzzles. Take care.